Hello everyone and welcome to the video on double angle and half angle identities. In this video we're going to see the double angle formulas and the half angle, and we're also going to see an alternate form of the double angle which also gets used a lot in calculus, which are called the power reducing formulas, but they kind of are, the book calls these alternate forms of the double angle identities. So let's start out here. Our skill objectives for this video are: 1, use the double angle and half angle identities to find exact values of certain trig functions. Number 2, use double angle and half angle identities to help verify identities. Conceptual objectives on this one. Number 1, understand that the double angle identities are derived from the sum identities. And number 2, understand that the half angle identities are derived from the double angle identities. You've actually already done some stuff with the double angle identities in class, because you had some problems where we looked at where they asked you to find like the sine of 2x or verify the identity type problem. And you can kind of use these double angle identities there. But this video is going to formalize those, and then we'll move on from there. Let's start out by recalling the the sum formulas that we have. Recall that the sine of a plus b is sine of a cosine b plus cosine a sine of b. The cosine of a plus b is cosine a cosine b minus sine a sine b. And the tangent of a plus b is tangent of a plus tangent of b over 1 minus tangent a tangent b. Now we talked about in the last class that sine, when we talk about 2a, that is a plus a. So when I do the sine of a plus a, what we saw in class before was that came out to be the sine of a cosine of a plus cosine of a sine of a. When we did this, it's the sine of the first, cosine of the second, plus, make that more of a plus, cosine of the first, sine of the second, which those are the same thing. So I get that the sine of 2a is equal to 2 times the sine of a cosine a. The next one we have deals with the tangent formula. The tangent of 2a is the tangent of a plus a. So again, we're going to go back up to this formula. We're going to make a and all the b's into a's. And what I'm going to get when I do that is this is going to equal, make a pen, equal the tangent of a plus the tangent of a over 1 minus tangent of a times tangent of a. And so when I simplify that, I find that the tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. Now we get to the cosine of 2a. Now cosine of 2a is a little bit different, because of the fact that there actually are 3 versions of this. Now the first one is real easy to come up with. We know that from what we saw before, the cosine sum formula is the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. So this whole thing is going to equal cosine of a times the cosine of the second, which is also a, minus the sine of the first, which is a, times the sine of the second, which is also a. And so I get that this is cosine squared a minus sine squared a. So that's one version right here of the cosine double angle formula. But notice here we do have trig function squared. So what happens on this is I can use the Pythagorean identities to help me come up with alternate versions here. So in the first case, I know that cosine squared is also equal to 1 minus sine squared. So I can say that this is equal to 1 minus sine squared a minus sine squared a. And when I combine the like terms, in this case, that will come out to be 1 minus 2 sine squared a. The last one we have is using the same idea. We're going to start out with that we have our We know the cosine of 2a is equal to cosine squared a minus sine squared a. And again, by the Pythagorean identity this time, I know that sine squared is equal to 1 minus cosine squared. So I can say this is equal to cosine squared a minus 1 minus cosine squared a. When I distribute that negative sign, I get cosine squared a minus 1 plus cosine squared a. Or I get that this is equal to 2 cosine squared a minus 1. So in this case, we do have, and it's important for you to recognize this, that we do have three versions of the cosine of the double angle formula for cosine. 1, 2, and 3. And in the problems that you work in, it's not going to make a difference either which one you use, though all three will give the right answer. It's just a matter of choice on which one is going to be the best solution for you, which one is going to give you be the easiest to use. Let's look at an example here. In the first example, I am told that the sine of x is 1 over the square root of 5. And I know cosine of x is less than 0. So, and they want us to find the cosine of 2x. Okay. Well, in this case, the fact that the cosine of x is less than 0 really doesn't make much difference for me because I have a double angle formula. I know one of the versions for the cosine of 2x in this case is that the cosine of 2x is equal to 1 minus 2 sine squared x. So in this case, I know that this is going to be 1 minus 2 times 1 over the square root of 5, that thing squared, which will equal 1 minus, well, 1 over the square root of 5 squared is going to be 1/5, so it's going to be 1 minus 2/5, which equals 3/5. So in this case, the cosine of 2x is equal to 3 over 5. Another one that they'll give you is, like we see in the second one, where they want us to simplify this. We're told that 2 times the tangent of pi over 8 is 1 minus tangent squared of pi over 8. Well, looking at that, that matches up almost exactly with, not almost, it does match up exactly with the tangent, the double angle formula for tangent. So I know in this case that this whole thing is equal to the tangent of 2 times pi over 8, which comes out to be the tangent of pi over 4, which we know that is equal to 1. So that would be the final answer on that particular problem. Now what they're going to want you to do is, in this case, is verify the identity, and we want to use the double angle formulas as much as possible. So in this case, this is where it's going to be a little bit different than what we've done before. Usually I would say on this one, the messy start with the messy side. But in this case, since I want to try applying one of the double angle formulas, I'm going to go through and work on the other side. So I know in this case that for cosecant of 4x, so I'll start out with 4 cosecant of 4x. And I know that's 4 over the sine of 4x. Well, that I can think of as 4 over the sine of 2 times 2x, which kind of makes it look like a double angle. And so this is going to equal, that equals 4 over, by the double angle formula, sine of 2a is 2 times the sine of a cosine of a. So it's going to be 2 times the sine of 2x cosine of 2x. And now the other thing I can do at this point is I can reduce this. That 2 drops out, and that will make that a 2 in the numerator. And so what I have right now is that we are equal to 2 over the sine of 2x cosine of 2x. Well, the next thing I'm going to do on this one is I'm going to use the double angle formula again. And I know that the sine of 2x, that is going to be 2 over The sine of 2x is going to be 2 sine x cosine x. Now we're going to leave the cosine of 2x there. And the reason I'm going to do that is you notice where I end up, I still need to have a cosine of 2x in there. So times the cosine of 2x. And now in this case, again, as before, the 2's here drop off. So right now I have 1 over sine x cosine 2x. But remember, 1 over the sine of x, 1 over the cosine of x, that 1 over sine x cosine x would just become cosecant x secant x over cosine 2x, or because multiplication can be done in any order, I know that would be secant x cosecant x over the cosine of 2x, which then matches up with exactly what I have, and so we now have verified this identity. At this point, pause the video, make sure you're comfortable with everything I did, and if you have any questions, make sure to note them and be sure to ask about them at the beginning of our next class. Now we get to the alternate forms of the double angle formula. These are also called the power reducing formulas. These get used a lot more in calculus than so much here. Now I'm going to show you an example of the use of these here, but for the most part, these are not ones that you're going to be applying except in very specific conditions. In this case, and really these all come from the cosine double angle formula. Remember, we have the 3 versions of those. And it's really those last 2 we're going to look at. I know that the cosine of 2a is 1 minus 2 sine squared of a. And so what I'm going to do is take this and solve it for sine squared. So I subtract 1. I divide by negative 2. And when I simplify that, because of the negative sign there, I can change that around. I get that sine squared a equals 1 minus the cosine of 2a over 2. Doing the same thing with the cosine of 2a, which is 2 cosine squared a minus 1. Now this one simply solves for the cosine squared a lot faster because I don't have to deal with a negative sign. I add 1 to both sides, then divide by 2, and I get cosine squared a is 1 plus cosine 2a over 2. Now using these 2 versions, we want to find the tangent squared of a. Well, the tangent squared we know is sine squared of a over cosine squared a, and by using these 2 formulas, I put those in there and simplify it. I get that tangent squared a is 1 minus the cosine of 2a over 1 plus the cosine of 2a. Make sure you're comfortable with how I went through and derived all of these formulas. And again, if you have questions, note them in your notes and be sure to ask about them at our next class. As I said before, that most of the time you're not going to be using these ones right here. There could be special times when you would. In this case, this is a problem from the book. I think it's problem 36. I can't remember. It's either 32 or 36, I think. And what it is it's the cosine to the 4th of x plus sine to the 4th of x equals 1 minus 1/2 sine of 2x. Or it should be sine squared of 2x. So let's put that squared in there. And so what we want to do on this one, we're going to go through on this one and we're going to use these power reducing formulas and we're going to go and simplify things from there. So the first thing you have to do on this one to use the power reducing formulas is to go through and think of the cosine to the 4th as cosine squared x, that thing squared, and the sine to the 4th as sine squared x, that thing squared as well. Now, I know cosine squared x by the power reducing formula that we saw. Cosine squared x is 1 plus the cosine of 2x over 2, and it's that thing being squared. And sine squared of x is 1 minus the cosine of 2x over 2, that being squared. Now the next thing I have to do is I have to go and square everything. So what I did here is when I square the 2 on the bottom, that's going to give me a 1/4. And that's why you see that's where these 1/4 come from there. And in the top, I have to FOIL that. So when I multiply out the top there, I will get 1 plus the cosine, or 2 cosine 2x plus cosine squared 2x plus 1/4 times, when I FOIL that out, I'll get 1 minus 2 cosine 2x plus cosine squared 2x. At this point, I can pull out the 1/4, and then it's a matter of just combining all the like terms. The 1 and the 1 combined would be 2. The 2 cosine 2x minus 2 cosine 2x, those cancel out. And I have cosine squared 2x plus cosine squared 2x. I get 2 cosine squared 2x. At this point, I again pulled out the 2, the common factor of 2. So when I pulled that out, I was left with 1 plus the cosine squared 2x inside, and 1/4 times 2 would give me 1/2. And so really to finish this one up, what I did is I replaced the cosine squared 2x with 1 minus sine squared 2x by Pythagorean identity, combine the like terms, and there should be another parenthesis right there, and then distributing the 1/2, 1/2 times 2 will give me 1 minus 1/2 sine squared 2x. So here was an example that we had where I had to use the power reducing formulas. There is a problem I think you're going to do in your book where this, instead of a cosine to the 4th plus sine to the 4th, you have a cosine to the 4th minus sine to the 4th. Now in that particular problem, you can do this, or you can recognize that that is also a difference of 2 squares. I would suggest trying to use difference of 2 squares on that particular problem. It will make your life a lot easier. Again, as we did before, look over this, make sure you're comfortable with everything that I've done in this problem. And if you have any questions, make sure to note them and ask about them in our next class. Now let's look at the derivation of the half-angle identities. And really those all come from these three here, the double angle formula, or the power reducing formulas that we've just had. What I'm going to do though is I'm going to make a little change on this to get it to be in that half-angle form. Now, and what we're going to do is we're going to let x equal 2a, and so therefore a is equal to x over 2. So this power reducing formula becomes here, sine squared of x over 2 equals 1 minus cosine x divided by 2. Cosine squared of x over 2 is 1 plus the cosine of x divided by 2. And the tangent squared of x over 2 is 1 minus cosine x over 1 plus cosine x. Now in this case, and this is one of the things you have to be aware of with these, when we solve for the sine, cosine, or tangent of x over 2, it is going to require we take a square root. And because it's a square root, we do have the plus or minus. That's why you'll see sine of x over 2 is plus or minus the square root of 1 minus x cosine of x over 2. Cosine of x over 2 is plus or minus the square root of 1 plus the cosine of x over 2. And in this first tangent one, we have the plus or minus. Now this plus or minus is behaving differently than what you've had to deal with in the past. In the past, when you've dealt with a plus or minus, it meant that you had to include both solutions. In this case right here, you have to identify if it is going to be a plus or if it's going to be a minus, if it's going to be a positive or negative. And you're going to do that based on some information that they also give you about that angle. Now the tangent formula that you have, this one you can use some simplification, some identities, and this thing right here is also equivalent to sine x over 1 plus cosine x, or 1 minus cosine x over sine x. Now you can again use either one of those. Now typically though, what they do is that we will use whichever one is going to make our life easier. In other words, the angle that you're putting in for x, when you look at it, if it involves a cosine value, if the cosine would be something that doesn't involve a square root, then I would end up using this one. If the sine is a value that doesn't involve a square root, I would probably use this one. If both of them involve a square root, I'm probably going to go with this one because it will be easier to rationalize that one than it would be to rationalize that particular one. So you want to pick which one you have there based on which one's going to make your life the easiest as possible. And so a knowledge of the unit circle there is real helpful. Now let's take a look at a couple examples here. in terms of working with these. In the first one, I want to find the exact value of the sine of 75 degrees. Now, you've dealt with this in the sum and difference formulas. Now we're going to look at this in terms of the half-angle formula. Now, here is one thing that does cause problems for students on this. It's what is x in this problem? Well, in this case, I want to find the sine of 75 degrees. 75 degrees doesn't appear on the unit circle. And so, in this case, x over 2 is actually, the sine is actually equal to 75. And so, x is going to be 150 degrees. So, I can say, in this case, that the sine of 75 degrees is plus or minus the square root of 1 minus the cosine of 150 degrees over 2. Now, a couple of things you have with this one. Number one, I know sine of 75 is a positive value, so I can just think of that as a positive square root. I don't even need to use the symbols. The other thing you're going to have is that you're going to be dealing with square roots under square roots in this case. And so you've got to, and you're going to be asked to simplify that. Well, I know the cosine of 150 degrees is negative square root 3 over 2. And so I now know that the sine of 75 degrees is going to be the square root of 1 plus the square root of 3 over 2, that whole thing over 2. Now what I'd like you to do right now is I want you to pause this video and I want you to simplify that expression underneath that square root. And once you do, come back and we'll talk about what that answer, how that would simplify. Welcome back. When you simplify this one, you should have gotten the square root of 2 plus the square root of 3. That whole thing is under the square root all over this 2, which is outside the square root. Let's see how that came about. We started out here. Well, in this case, to simplify that numerator, I would have to get a common denominator. So I want to think of that 1 as 2 over 2. And so when I add those together, I'll get 2 plus the square root of 3 over 2. And we're still over this 2 as well. Well, dividing by 2 is the same as multiplying by 1/2. So when I multiply this numerator by 1/2, I will now have the square root of 2 plus the square root of 3 over 4. And then working with square roots, I can take the square root of the top and bottom. Square root of the top is the square root of 2 plus the square root of 3. And in the bottom, the square root of 4 is 2. And so therefore, that would be the simplified version. That would be the exact value of the sine of 75 degrees. Now let's take a look at the next one. And in this case, in the first one, we had a numerical value for the angle that we could tell where that fell, what quadrant it would fall in, and therefore whether or not it should be the sign should have been positive in this case. In this case, what we're going to be told is we're told that the cosine of x is negative 5/3, and sine of x is less than 0. So sine of x is also negative. So that tells me that the terminal side of this angle is going to fall in quadrant 3. And I know quadrant 3 tells me that because it's in quadrant 3 angles go between pi and 3 pi over 2. So I know that in this case that x has got to be between pi and 3 pi over 2. Now that means if x is between pi and 3 pi over 2, I need to find out where x over 2 is. That's what's going to be important for me. And in this case, to find out where x over 2 is, I can just go through and divide everything here by 2, or multiply everything by 1/2. And when I do that, what I'll get is that pi over 2 is less than x over 2, which is less than 3 pi over 4. So that tells me that these angles that are possible for x over 2 fall between pi over 2 and 3 pi over 4, which that means we are in quadrant 2, and in quadrant 2 then the cosine value is going to be negative. So in this case, I know I'm going to use the cosine half angle. I know that the cosine of x over 2 is plus or minus 1. In this case, it's going to be minus the square root of 1 plus the cosine of x all over 2. And so in this case, the cosine of x, we're told, is negative 5 over 13. And so I'm going to get that this is going to equal, that will equal the opposite of, or negative, square root of 1 minus 5 over 13 over 2. And getting a common denominator, which would be 13 over 13, this is going to be the square root, a negative square root of 13 over 13 minus 5 over 13 is going to be 8 over 13 all over 2, which dividing by 2 is the same as multiplying by 1/2, so that's going to be the opposite of the square root of 1/2 times 8 over 13 is going to be 4 over 13, which will be negative 2 over the square root of 13, which is negative 2 square root 13 over 13. And that would be my final answer on this one. The cosine of x over 2 is going to be negative 2 times the square root of 13 over 13. Another one that they're going to ask you to do, and it's very similar to what we saw before, we're going to be asked to simplify something. And in this case, we're being asked to simplify 1 minus the cosine of 150 degrees over the sine of 150 degrees. And again, looking at the half-angle formulas, you should recognize that as being one of the tangents. And so we can say that this one here is actually just equal to the tangent of 75 degrees. Again, as with all of these, make sure to double check all my work and make sure you're comfortable with everything. And if you do have questions, please make a note of them in your notes and ask about them at the next class. The last question that we have is we want to verify the identity that secant squared of a over 2 is equal to 2 times 1 minus the cosine of a over the sine squared of a. And they want us to use the half-angle formulas on this one. So really, when they see that, that's telling us we're going to work with this side, even though this side probably appears to be the messiest. And so one of the things I'm going to do on this one is I'm going to go initially use the fact that secant squared of a over 2 is going to be equal to 1. The secant squared of a over 2 is equal to 1 over cosine squared of a over 2. Now, we want to use the half-angle formulas. Now, if you remember, the cosine of a over 2 is equal to plus or minus the square root of 1 plus the cosine of a over 2. Well, in this case, when I square that, that's going to get rid of the square root. So I can say this is equal to 1 over 1 plus the cosine of a over 2, which is just the reciprocal, so that gives me 2 over 1 plus the cosine of a. Now, I need that bottom become sine squared. Now, there's only one identity that ties cosine squared and sine squared with a cosine, and that is the Pythagorean identity. And so to do that, I need to have a 1 minus. I know I'm going to need this to be a 1 minus cosine squared a. So that tells me right away that I'm going to multiply top and bottom by 1 minus cosine of a. That's a form of 1. And so when I do that, that will become 2 times 1 minus the cosine of a, which is what I want in my numerator, over, that's going to be a difference of 2 squares, 1 minus cosine squared a. And so the final result, 1 minus cosine squared a, is equal to sine squared a. So I get 2 times 1 minus cosine of a all over sine squared a. And so it's all done. So we are done. And way a lot of times you'll see this is just with a QED. It's a Latin expression saying it's basically meaning it's now proven. So we have now shown that secant squared of a over 2 is equal to 2 times 1 minus the cosine of a over the sine squared of a. So that covers it. And with that, we have now concluded this video. It might be a little bit longer than I hoped it would be, but there's some examples there. And again, make sure you're comfortable with all these the examples we did here. Make sure you note any questions you have and ask about them in our next class. And with that, I will see you in our next class. So hope everything's going well, and see you then.